Assalamualaikum warahmatullahi wabarakatuh. We're almost complete. The fourth and final characteristic, security. Now, this might be the most impressive part of blockchain. We already talked about how it's distributed, so there's no single point of failure. But what about tampering? What stops someone from changing the transaction records? The answer is cryptography. Let's find out how it works. The key security property of blockchain is data integrity, which means the data cannot be secretly changed. Transaction data must be a permanent record. Once it's written, it should stay exactly as is forever. If someone could secretly edit all transactions, the entire system would be untrustworthy. Blockchain solves this using cryptography, a mathematical approach to protecting data. So, how exactly does cryptography protect the integrity of blockchain data? Let's break it down. In cybersecurity, we talk about three core properties, often called the CIA triad: confidentiality, keeping data private so only authorized people can read it; integrity, making sure data doesn't get altered or corrupted; availability, ensuring the data is accessible when you need it. Blockchain mainly addresses two of those. Integrity, this is where blockchain really shines, using cryptographic hash functions. Availability, covered by the distributed architecture, data is always somewhere accessible. Confidentiality? Well, actually, blockchain offers transparency. Data is not to be kept confidential. But when confidentiality matters, we can use cryptography to protect data privacy. Let's zoom in on integrity, because that's blockchain's core security superpower. Why is data integrity so critical for transaction data? Remember, transaction data is a permanent record of an event. It's supposed to capture exactly what happened at a specific moment in time. Imagine if someone could secretly go back and change a transaction record, say, changing the amount of a payment or who sent money to whom. The validity of the entire transaction would be compromised. If you can't trust that the records are accurate and unchanged, then the whole system becomes unreliable. You'd have no way of knowing what really happened. That's why data integrity isn't just a nice to have. It's absolutely essential for any transaction system. And blockchain's use of cryptography is what makes this guarantee possible. So, what exactly is cryptography? Cryptography is the science and set of techniques for encrypting information, transforming data into a form that's protected. In everyday life, cryptography is working behind the scenes constantly. When you send a WhatsApp message, it's encrypted so only the recipient can read it. That's cryptography in transmission. When your password is stored in a database, it's not stored in plain text. It's hashed and encrypted. That's cryptography in storage. Blockchain uses cryptography specifically for that second type, securing data in storage, to make sure that once data is written, it cannot be secretly changed. The specific tool used for this is called a hash function. Let's take a look. A hash function is a mathematical function that takes any input data of any length and produces a fixed length output called a hash value. Let's break that down. Input data could be a single word, a sentence, or an entire document, any size at all. Hash value, the output, always the same fixed length no matter what the input is. For example, the SHA-256 hash function always produces a 256-bit output, whether your input is one word or an entire novel. Think of it like a fingerprint machine. No matter who you are, tall, short, young, old, the machine produces a fingerprint. Your fingerprint uniquely identifies you, and a hash value uniquely identifies your data. This fingerprint property is what makes hash functions so powerful for security. Not every hash function is suitable for security. A cryptographic hash function needs to have 5 special properties. One way, you can go from data to hash easily, but you cannot reverse engineer the original data from the hash. It's a one-way street. Fast. Computing the hash should be quick and efficient. Deterministic. The same input always produces the same output, every single time. No randomness. Anti-collision. It should be virtually impossible to find two different inputs that produce the same hash. Every piece of data gets its own unique fingerprint. Pseudo-random. Even a tiny change in the input, like changing one single character, should produce a completely different hash output. The changes look random and unpredictable. These 5 properties together make cryptographic hash functions an incredibly powerful tool for protecting data integrity. Now, here's the magic. How hashing makes the blockchain tamper-proof. Each blocks the hash value of the previous block. So block n+1 stores a hash that was computed from block n. This creates a cryptographic chain. If anyone tries to secretly alter data in block n, even changing just one tiny character, the hash value of that block completely changes. But wait, block n+1 contains the old hash of block n. Now there's a mismatch. The chain is broken. The tampering is immediately detectable. To successfully tamper without being caught, an attacker would have to recalculate and replace the hashes of block n+1, block n+2, every single block after it, across all copies in the entire distributed network simultaneously. That's computationally practically impossible. This is why blockchain data is considered immutable. Once written, it can't be secretly changed. Okay, that's for now. Stay tuned for the next video where we'll dive even deeper. Thanks for watching. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.